Hi everyone, it's Ian from QTips, and in this video I want to show you how to georeference historical Google Earth imagery in QGIS, and we will use a real-world example and we'll have a look at the catastrophic failure of the Aral Sea as our example for comparing historical imagery. And what I've done for this video is I've created a folder on my desktop and I've called it Aral Sea. And inside that folder, I've currently got a QGIS project, and I'll open up that QGIS project to show you what it is. Just see if I can. I'm trying to minimize this, but I'll just minimize it that way. And then in QGIS, that QGIS project, all I've got is I've got the world boundaries, just so I can kind of get an idea of where I am in the world. Okay, so that world country boundaries, those admin boundaries, it's a shapefile, and you can pretty much Google search that and download it from somewhere online, but you don't need it for this video. Okay, so if you'd like to follow on, then what you would need to do is just have Google Earth Pro loaded on your desktop, and you can download that. If you go into Google and you search for Google Earth Pro, download, let's say, and then click on Earth versions. So the first result that comes up, and then scroll down. You want to scroll down to the one that says Google Earth Pro on desktop. So if you click on that, you should be able to download the installation files and then just run that, and then you will have Google Earth Pro on your desktop. So I'm going to open that now and then show you what we're going to do. So I have covered georeferencing before using historical imagery, but I think it's worth revisiting because the location of that georeferencing tool in QGIS has moved. Okay, so for this example, we're going to have a look at an area that has undergone significant change over time, and the Aral Sea is the example I'm going to use. And I came across this on a video. Another YouTube content creator had created a video on the Aral Sea, which I found very interesting. So I thought it might be useful to use it in a georeferencing example. So let's go ahead and find the Aral Sea. So in your search bar, just type in Aral Sea, and that's how you spell it. There's no I there, although you do apparently pronounce it Arial. So then click search, and it's going to zoom us to the Aral Sea. There we go. Okay, that's pretty much far enough. And this Aral Sea is a good example. It's a nice comparison for historical imagery because it has shrunk dramatically over the years due to large-scale irrigation. When in the 1950s, the Soviet Union expanded cotton farming in the regions. So we currently got Kazakhstan and Uzbekistan, which were former states of the USSR, and they had cotton growing in various agricultural zones. So this is a cotton growing zone down here, and I think the one for Kazakhstan is up here somewhere. Okay, so with the expansion of these cotton growing projects, there was the need for quite a high level irrigation. And what happened is there's two main rivers which feed into the Aral Sea. Now the Aral Sea is an endorheic system, meaning that the water flows in, but it doesn't flow out. And it flows in mainly from two main rivers, and those rivers are the river in the north, which is called the Sirdarya. So that's this river up here. Okay, so that flows into the north, so that's in Kazakhstan. Let's see, Sirdarya. Okay, so that freshwater river, and these rivers are interesting in that their main source of water is from ice melt, from glacial melt. If we zoom slightly to the east, you can see there's actually a very mountainous region with lots of glaciers and snow. So that's their source, and then the other river in the south, which is called the what is that river called again? It's the Amu Darya in the south. Okay, so the Amu Darya is in Uzbekistan and the Sirdarya is in Kazakhstan. So what essentially happened is the poor agricultural practices from the USSR, they just dug open channels and canals to move the water from the river into these agricultural pastures. And the water management was quite poorly practiced, and there was a lot of evaporation. And then since the canals weren't even lined, they weren't even concrete canals, they were just earth canals, the water just disappeared. So So it was only a matter of time before that started impacting the Aral Sea, because there was not nearly as much water flowing in anymore. And in the video I watched, they discussed some intervention. So in the north, in Kazakhstan, there has been some intervention over time in that they built this little earth dam over here to prevent water leaking or basically flowing out of the north part of the sea into the southern pan with this little earth dam, and that was built in the late 90s. It had an issue in 99 where there was some devastation where that dam broke. It's now a permanent dam wall, and I do believe they are, according to the video, they are going to be adding to this wall just to try and improve the water level in that northern part. And that small intervention has actually had a dramatic increase. And if you watch the video, they cover those changes quite nicely. And I'll maybe leave a link. Actually, I'll definitely leave a link to that video in the video description so that you guys can go and watch that video if you find that sort of thing interesting. Okay, so what we're going to do is we're going to use this as an example to compare historical imagery over time and see how the Aral Sea has gradually evaporated into a desert pan over time. And we're going to do that in QGIS and Google Earth Pro. So what we need to do is we need to export imagery from Google Earth Pro and then georeference it in QGIS. So we're going to start off by creating some ground control points. And traditionally, a surveyor, if they were doing some aerial photography, or if they wanted to do a survey, they would go into the field and they would paint a couple of rocks white, and then they would capture the location of those rocks using a theodolite or whatever other equipment they would use. And then when they took the photograph, they would be able to see the white heap of rocks, and then they would know that that point was that location or XY value, and they had a control point. So we essentially are going to create control points using place marks in Google Earth Pro. So we'll start off by scrolling or moving our historical imagery back to 1973. So in Google Earth Pro, you want to click on the little icon that looks like a clock with a little wind back green arrow. If you click on that, it'll give you the options to wind back the clock, and we're going to go all the way back to 1973, and then you will see the imagery from 1973. So now 1973 is already a good 20 years on from the 1950s when they first started this cotton growing project by the USSR. So already we've had quite a bit of evaporation. So we don't have imagery further than that, but it's a good starting point. We can see that the Aral Sea is still a reasonably good body of water. So it's something to compare to what it looks like today. So we are going to create some ground control points. But the first thing you want to do before you export any imagery from Google Earth Pro is make sure that the terrain is turned off. Okay, now if this terrain is on, then it's going to try and create a three-dimensional look to your imagery. We want that off so it's a flat image. The other thing is we want north to be north. So if you just click on north, it should return to north, and remove any tilt. So if you have any tilt, so yeah, what I'm going to do is I'm just going to tilt my globe like that. Okay, so what you need to do is untilt it. And there's actually a very easy way to do that. If you just click on R on your keyboard, click R, it removes all the tilts, and it returns north is north again. Okay, so let's turn off the borders as well. We don't want to see anything else. I'm turning off the primary database. And then we also don't want to see this little aerial jobby here. So what we can do is I think we can clear that. If we click on history and clear history, there we go. And then we'll close down search. And then I'm just using my scroll wheel on my mouse just to zoom out so that we can use the extent of the imagery from 1973 to create some ground control points. So just before I do that, I'm clicking R again just to make sure that north is north. And let's add our ground control points. So click on your place mark option to add your first place mark. And this one we will name A, so ground control point A. And we want to change the icon to something that is symmetrical. So click on the little pin and then choose the little diamond. And we'll make the scale 0.5. So you might need to delete that 0.5. And let's change the color to something we can see, which is like a nice blue. I think that will come blue. Yeah, there we go. It's gone blue. And if we click on OK, that'll implement that graphical change to our icon. And we don't need to see the A. So what we can do is we can click on Style and Color. And where it says Label, just make the label opacity 0, and then that will remove the A. But it's currently not in the wrong place, but it's not in a very useful place. So what I want to do is I'm going to drag that icon up into the top left-hand corner, just so it overlaps with our imagery from 1973, and then click OK. And then we just need to repeat that step 3 more times. So let's add a place mark. We'll call this B. So you can just type B immediately to get B. And now let's move it up into the top right-hand corner and click OK. You'll see it's kept the changes, so we don't need to do those edits again. New place mark. We'll call this one C. Now C, oh, I didn't grab it. I need to grab it. C can be down here. And then OK. And then a new place mark. And this one can be D. And then let's move D down here. Okay, so the idea now is that when we export this image, we will be able to see these ground control points and then use them in QGIS by exporting these into a KML and then loading them in QGIS. So we're going to have a vector layer in QGIS, and then we will still see the image representing those little ground control points when we export these. And we'll use those in the georeferencer. So what we need to do is convert these into a single layer. So what we'll do under My Places, right click and then select Add and Folder. And the new folder name can just be GCP for ground control points. And then OK. And then what we want to do is just drag all of those points. So these are currently separate points. Drag them all and drop them into GCP. There we go. So now we can export the folder, and it will treat them all as one layer. So let's right click and then select Save Places As, and we'll go to my desktop. So my desktop, I created that folder called Aral Sea, and I'll just pop them in there. GCP KMZ. I'm going to make them a KML. I think QGIS these days can read KMZ as well, but I just in practice I've always converted them to KML, so I'm leaving it as a KML. So let's click Save. And we're almost done in Google Earth, except for the fact that we now want to export these images. So let's go back into QGIS and add that little layer. So we're going to click on the Data Source Manager, navigate to your desktop or wherever you stored them if you are following along. So I'm going to my desktop, Aral Sea, and select the GCP, and then add layers and close. There they are, but they are in a different icon. So what I want to do is I'm going to select it, open up the layer styling panel, and change it from embedded symbols to single symbol. Oh, there they are down there. And then I'm going to also label them. So click on ABC, the label, single labels, name, turn on the text buffer, and then let's zoom in. And then maybe I'll change the icon as well. I'll turn it into a blue diamond. There we go. Okay, so there are our ground control points added as a vector layer. So let's save that project. Now, when I go back into Google Earth Pro and export these, I'll be able to use them to georeference this image. So let's export the 1973 imagery. So we're going to do that from the File menu. Select File, Save, Save Image. And then it gives you some map options. Now we don't need the legend or title or north arrow, so let's turn those off. So under map options, just turn them off. And now we need to select the resolution. So I'm not going to go for the maximum resolution. I'm just going to go for something that's useful for this tutorial. So I'm going to go 4K. So select 4K. And you'll see that it's outside of the exportable area. So I just want to zoom out ever so slightly. I do need to see those ground control points. Otherwise, this exercise is pointless. Okay, I'm going to click on R again, just to reorient. Now, I'm going to export this image, and then I'm going to scroll through forward in history, and I'm going to export those images as well. It's important from this stage not to pan or change the scale of your image, because I want those images to export the exact same location data. Okay, so that's the important thing to note from now on. So with the first one selected, if I'm happy with the extent of my imagery, I can click on save. So save image. And then just go choose a location, desktop, Aral Sea, and this can be 1973. And then save. There we go, done. So let's go forward to 1984. So let's go 10 years into the future. See, now I haven't changed anything. I'm just clicking, I'm changing the date, but I haven't panned. Remember, don't pan, don't scale. And then click save. And this can be 1984. And save. 1994. So we can already see the sea changing. Move this across. 1994. Save. And then 2004. You get the picture now. Now, we can do this for any part of the world. You'll be able to compare any location using the same process. And let's do one last one. Let's do 2014. And done. So now we are done with Google Earth. We can just minimize that. And let's go back into QGIS. Then what we need to do next is we need to access the Georeferencer, and you can do that from the layer menu. Now, it used to be a core plugin. Well, before, I think it was always a core plugin, but you had to activate it. But now it's part of our menu, so it's part of the layer menu. So this is where it is. If you don't see it anywhere, you might be on a very old version of QGIS, but I'm currently running QGIS, what is it, the latest long-term release in, what are we in now? April 2026 is Solothurn, if that's how you pronounce it, 344. Okay, so under the menu, layer, select Georeferencer. And now you'll see my Georeferencer is docked. Yours might not be docked. If yours is sitting as a separate window, what you can do is just drag it down and drop it underneath your map view to dock it, which I like to do. I'm going to turn off the layer styling because I don't need to see that. And then what I also want to do, actually that's fine, so we're good. But I do want to turn on the snapping options. So from the snapping toolbar, if you don't see it, you also need to activate that. Just right click up here in a blank space on your menu and turn on snapping toolbar. And you want to turn on your snapping, so make sure it's activated. And then click on the little option to advance to do some advanced configuration. Go to Open Snapping Options, select Advanced Configuration, and select GCP. So now what we're going to be able to do is snap onto our ground control point. So the vector, we'll be able to snap onto the vector once we've identified the ground control point on our raster. So with that, we can close that down. And let's go ahead and add our raster from 1973. So click on the Open Raster button under your Georeferencer. And navigate to your folder. So for me, it's desktop, Aral Sea, and then select 1973 or whatever image you're looking to georeference. And we'll start with the first one. So click Open. And with any, like those little ground control points that we added will be visible. There we go, nice and visible. Now yours, if you sent it out at a different resolution, it might not look exactly the same. It might look a bit better, but your image will be quite big. So we're going to start by adding a ground control point. So zoom into the top left-hand one, and as close as you can to the center of this diamond, click your first ground control point. Then we are going to select the next one from the map canvas to enter the coordinate. And with our snapping option set, we can snap onto A, and then click OK. So it's nice and quick that way, and you get as close as you can to the actual vector point. And we'll do the same for the second one, which was point B. From map, click on B, OK, scroll out, scroll in or zoom in to D, close as you can to the middle, from map canvas, C, okay. And you'll see there's a bit of a RMS error there, but we're not going to worry about that. And then as close as you can to the center of point, I see that's D and that's C. Okay, so point D, from map canvas, D, and then okay. And we now have 4 control points added. That'll be enough for us to georeference this image. Okay, so before we do that, let's just go have a look at the transformation settings. So click on transformation settings, and the transformation type, we are going to create a world file. So we're just going to go for linear, and we're going to choose the same coordinate reference system as our map view. So I'm currently in pseudo transverse Mercator, which is EPSG 3857. And I did choose this because it is the same as the Google imagery that gets exported or what would you say, streamed in using the quick map services option. So if I want to compare it to the other imagery that we have in quick map services, it's going to be the same. So let's choose pseudo Mercator. And now we're going to create a world file. So we're not creating a new modified file, image file. We're just going to create a text file, which is a world file. So with that, we can click OK. And we can click Run. And it will georeference and reference that first image. There we go. And it imports it into the project. Now it says it doesn't know what the coordinate projection or the coordinate reference system is. That's fine. We could assign it here if we want to by just going right click, layer CRS, and then choose 3857. But that's fine. And let's move it underneath everything. There we go. Okay, so we have georeferenced 1973 and we have created a world file. We don't need to redo that whole process for the other images because they are in the exact same place. So the size of the image and the location of the various pixels representing the same data are in the same place. So all we have to now do is go and duplicate those world files for the new dates of the different images. So let's go to our aerial folder, and this is where we are. We see we've got one world file. Now a world file, if we just open it up, show you what that looks like. It's just a text file. So let's open with the notepad. There we go, and this is what a world file looks like. Okay, the first line is the size of I think it's the width of the pixel. The next two are orientations. The fourth line is the depth of the pixel, and then the next two lines are the XY value or the latitude and longitude of the very top left pixel. So if you know the size of each pixel and you know the location of the first top left pixel, then you can georeference the entire image. Okay, so that is what a world file is. The different image types used to have their own world file extensions. For instance, a JPEG used to be a JGW. A TIFF file, a TIFF used to be, the world file used to be a TIFF file world, TFW, but this WLD file or world file will be referenced by any of these images. So you don't need the JGW or the JGW anymore. The world file WLD is fine. Okay, so with that, let's close that down and let's duplicate this world file for these remaining images. So right click on that, select copy, right click and paste, and let's rename that to 1984, enter, and we'll repeat that step for the remaining images. Okay, so every one of our images now has a world file. Let's go back to QGIS and add those images, and then we can compare them. So we're done with the georeferencer. Let's turn that off. So under georeferencer file, select file and close georeferencer. And we don't need to keep those ground control points, so we'll discard those values from our table. And then let's zoom in a bit. Okay, so let's go ahead and add those other images now. And I'm going to do it from the browser. So if you select browser and you navigate to your desktop, so I need to go to users, Ian Wilson, desktop, Aral Sea, and then I'm just going to select all of them, drag them all and drop them into the map view. And let's put them in order. So let's go 1973 first, then it's 84, then 94, then 2004, then 2014. And now if we scroll through, so if I turn them on and off, so let's turn off 1973, so 10 years, let's see what happens. In 10 years, there's quite a big loss. Okay, so why and when might this be useful? I mean, you could just, for visual and presentation purposes, you can compare two different land practices, whether it's overgrazing or informal settlement development or anything, erosion or some natural disaster. You can compare the 2 years. And in this case, for instance, let's say this was on a much smaller scale. This is a wetland that's being devastated by some sort of practice. What you can do for 1973 is you can digitize the polygon for 1973, and then you calculate the area for that. You then digitize the polygon for 1984, and then you can see that within 10 years, you've lost so much surface area of your feature, whether it's a sea like this, or a wetland, or an estuary, or whatever it might be. So let's go to 1994 now. It's gradually getting smaller. 2004, and then 2014. And let's have a look. If we zoom in up here, the resolution is not that great, but 99 is when this little dam was built. So this is that dam I was talking about. Let's go back to 73. So 73, they still joined. By 1984, they're almost broken. Okay, and then by 94, it actually is broken, but they build the little dam wall in here. You can't really see it. But then this sea starts getting bigger and bigger. There's the dam wall in there. And by 2014, you can see that dam and the sea level has risen quite a bit. Sea, inland lake, inland sea. I think they refer to it as a sea. So the northern sea level has come up. And apparently that had a dramatic effect. If you go and have a look at that video, the salinity of the water immediately within a year had returned to previous levels. The fish population grew quite quickly, and the global economy, well, not the global, the local fishing industry changed quite a bit, and quite an interesting video if you go and watch that. Just something I want to point out to the more observant among you. You'll see that the imagery doesn't line up 100% with my vector KML layer. And that is because I created a world file. I didn't warp this image in any way, so there's no rotation values. So that's just a little deficiency and maybe something to look out for. It might be worth choosing a different transformation type, something like a polynomial 1 or polynomial 2, and that will, whichever transformation type will be determined by how many ground control points you select. But for this example, I think it's served a purpose, but just be aware that there can be some transformation issues with world files as they don't warp the imagery. So in that case, in this instance, we haven't got a complete or 100% match. On a smaller scale, it might not be such an issue, but on a big scale like this, you might find some boundaries don't line up 100%. So I just wanted to point that out. So that's all I wanted to get to in this video. A bit of a longer one. I hope you managed to stick through it. If you've got to this stage of the video, I'm thankful for that. Thanks for joining me in this video. And that's georeferencing using QGIS. So that's how you can use Google Earth Pro historical imagery and QGIS to compare those two data sets or various data sets from different historical times. That's it from me. I'm Ian from QTips. Till next time, cheers.